This video is section 12.3, inscribed angles. An inscribed angle is an angle whose vertex is on the circle and whose sides are the chords of the circle. An inscribed angle is angle A, B, C. Notice angle ABC cuts through part of the circle, cuts through the arc of a circle. This is referred to as the intercepted arc. So the angle is inscribed and the arc is referred to as the intercepted arc. Below are just a couple different ways the angles can be drawn. Notice all the vertices are on the edge of the circle. The only thing that's different is where the center of the circle is located, but they're still all inscribed angles. So here's an example. Which arc does angle A intercept? Angle A is an inscribed angle because its vertex is on the edge of a circle. Extend the chords, which are the sides, and notice that it's touching B through C. So the intercepted arc is arc DCB, or vice versa. Actually, it's a minor arc, so we name it with 2. So let's call it DB. Number 2 says which angle intercepts arc ABCD. So let's get rid of this. ABC is the intercepted arc. So which angle creates it? It looks like it's angle D. All right, next slide. Whoops. Key concept. When you talk about the measurement of an inscribed angle, it is half the measure of its intercepted arc. So if angle B is 36 degrees, then angle AC is, arc AC is 72. So the angle is always half, or the arc is double. And I have an animation that shows you that, in case you don't believe me. Notice the angle, it's labeled with a B down there, says it's 38 degrees, and the arc is 76. So it's double or half, depending on which way you're looking at it. And you can move the angle to make it larger or smaller, but the relationship between the two is that the intercepted arc is always half the angle length. So there's 110, 121. Let's make this intercepted arc to be 100, just so easy mental math, and look at the angle being 50. So this is where we're going to use it. Asking you to find the measure of angle A. Well, the arc is 16. The angle is half of it. So half of 116 makes this 58 degrees. A little bit more complex diagram for the second one. It's asking for the measure of arc BC, which is here. Notice that it corresponds to angle 48. So arc BC must be double, making it 96. Angle B. When angle B is extended, it's corresponding to arc AC, which is labeled 110 degrees. So half of 110 is 55. Angle C, lots of colors here, shoots out this way. And so its intercepted arc is AB, which happens to be what we're asking in letter D. We know that all the way around a circle is 360. And if we know that this portion of the circle is 110, and this other portion is 96, I can subtract from 360 to figure out that what's labeled in green is 154. So angle C must be half of that, which is 77. Couple more. These ones are a little bit more complex. So for letter A, I'm going to start with letter X. If I extend letter X, the inscribed angle is X, the intercepted arc is the 40, so x has to be 20. Looking at angle y is the inscribed angle. So its intercepted arc is 70 degrees, so y is 35 degrees. Look at w. If you extend angle w, it's actually relating to the diameter. If I erase this, I know that it's the diameter because it's going through the center. So that means that this whole arc up here is 180 degrees, so this angle must be 90. And then lastly, we need angle z. What I'm going to notice here, and you could extend angle z if you want to, and we can subtract from 360, but I notice that I have a triangle with one angle of 35, 90, so I'm able to find angle z by subtracting from 180. And when I do that, I get 55. All right, example letter B. Could you please add this 72? I was trying to modify the example and I forgot the arc measurement when I printed the packets. So please just add that 72 there for purpose of an example. Angle 2. If I extend angle 2, it's referring to this intercepted arc. But look for a moment at the angle that's labeled 38. It's referring to the exact same arc. So if the intercepted angle is 38 degrees, 38 degrees times 2, 76. So that means angle 2 must be 38 because it has to be halved to get back to the angle. Other thing, and I said for sake of an example, we have number 3. Extend 3, and 3 corresponds to this that I had you label 72, so I know 3 must be 36. Letter C is another quadrilateral, similar to the example on the previous page. So what I'm going to do with letter C is I'm going to start first by extending the angle 96. When you look at this problem, there's a lot of angles, there's a lot of variables, so knowing where to start can, I think, be the hardest part. I just chose to start with angle 96 to extend it. So when I did, I was left with this large intercepted arc that's labeled in red. I know that if the angle is 96, then that huge arc out here must be 192. Notice that part of it is already labeled 99, so I know then that this little piece must be 93. What else can we extend? I'm going to extend, let's try extending the 100. So when I extend the 100, the intercepted arc is what I'm labeling in green. Well, that entire arc must be 200, but part of it's already labeled 99. So this measurement here must be 101, which happens to be our first letter that we need. What else can we use? C looks like as it extends, it gets part of this value here, which is 101, and part of B. I can figure out what B is because as I go around the circle, I have the 93, I have the 99, I have the 101. So if I add everything up and subtract from 360, I get that B ends up equaling 67. This is getting pretty messy. Let me erase and label everything that I know right now. I found out that this arc up top was 93. I was given the 99. I found that the arc labeled A was 101, and I just subtracted all of those from 360 to get that B equals 67. So now to get C, C is this green intercepted arc, so it's half of the 101 added to the 67. So that divided by 2 gives me 84. And then letter D, If I extend D, it's the arc with the 93 and the 67. So 93 plus 67 divided by 2 ends up giving me 80. Because I'm at a four-sided figure inside, I know that they must equal 360, so I'm going to go ahead and add them all up just to make sure we didn't goof anywhere. And when I add up all of those degrees, they all did add to 360, so I know I did it correctly. Okay, next page. Refresher, what is a tangent line? We discussed this in section 12.3. A tangent line is a line that intersects a circle only once. What is an inscribed angle? An inscribed angle is an angle whose vertex is on the circle and whose sides are chords. Here, what I want you to realize, I'm going to move this angle. Here's an inscribed angle. Here's a tangent. But if you notice, it really is an inscribed angle. Let me prove it to you. Okay, so here's an angle shown. BD is a tangent line. BC is a chord. So we really have an inscribed angle. And to prove it to you, look at the measurements. So we know that when you have an inscribed angle, its intercepted arc is always half. So the angle that you're looking at is actually right here. It's the 63, because that's the measure of the angle. And then that 127, it's really telling you is this red arc, because central angles equal that outside arc. So look what happens as I change this angle. So as I move that angle measurement, so there it's at, let's make it, try to get as close to 30 as possible. So there's 30. So it's telling you that this red arc is 60. If I make it larger, and I can move it anywhere around that we want to. So this outside angle is 120, and it's telling you then that this red arc is about 240. So what I'm trying to get at is the idea is that we know that an inscribed angle is an angle whose vertex is on the circle and whose sides are chords. But our connection or correction is that this side length doesn't have to be a chord. It can be a tangent as well. So can a tangent line create an inscribed angle? Yes. So our correction to this previous statement, an angle whose vertex is on the circle, that can't go anywhere. And it says whose sides are chords, or it needs to have one side that's a chord and one side be a tangent. So the same relationship holds, which is all the next slide is going to tell you. So the measure of an angle formed by a tangent and a chord is also considered an inscribed angle. What's the relationship between an inscribed angle and its intercepted arc? It's the same thing. So whether the whether the inscribed angle has sides that are both chords, or it has one chord and one tangent, the same relationship holds. Some examples, notice in number 16, the arc is 246. So half of that means it's going to be 123. This portion out here is 230, meaning this portion over here must be 130. Half of that is 65. Let's see, this angle is 115. Notice it's lying on a straight line. So if I subtract it from 180, I get 65. This angle is intercepting the circle with angle F. So when I double it, it's 130. The same relationship holds. Go ahead and try the last challenge problem. Due to the constraints of my free screen casting software, I'm going to have to record one more short video to show you the answer.